Welcome to solverfy.
We are given a sequence and we are asked to find a close form for the generating function for this sequence. In part A, the sequence is defined as a sub n is equal to 5 for all n equal to 0, 1, and so on. We have the generating function for this sequence g of x is equal to the sum from n equals 0 to infinity of a sub n x to the n, which in this case is going to be the sum from n equals 0 to infinity of 5x to the n. And we can pull a 5 out, so this is the sum from n equals 0 to infinity of x to the n. And recall that we have by a theorem, this is 5 times 1 over 1 minus x. So this is equal to 5 over 1 minus x. In part B, the sequence is defined as a sub n is equal to 3 to the n for all n. We have the generating function for this sequence, g of x is equal to the sum from n equals 0 to infinity of a sub n x to the n by definition. And this is equal to plugging in a sub n, the sum from n equals 0 to infinity of 3 to the n x to the n. And we can write this using power laws as the sum from n equals 0 to infinity of 3x to the n. And we have by a theorem that this is equal to 1 over 1 minus 3x. In part C, we're given the sequence a sub n, where a sub n equals 2 for n equal to 3, 4, and 5, and a sub 0 equals a sub 1 equals a sub 2 equals 0. The generating function for this sequence, g of x, is by definition the sum from n equals 0 to infinity of a sub n x to the n, which is equal to, substituting in the sequence, the sum from n equals 3 to infinity of 2 x to the n, which is equal to 2 times the sum from n equals 3 to infinity x to the n, which is equal to 2 times the sum from, and then we'll say, make the substitution t equals n minus 3. So this is now the sum from, well, if n is equal to 3, then t starts at 0, so t equals 0 to infinity of x to the, and then t is equal to n minus 3, so n is equal to t plus 3. And this is equal to 2 times x cubed times the sum from, and now changing back using n equals t, we have the sum from n equals 0 to infinity of x to the n. And this is equal to 2x cubed, and by a theorem, times 1 over 1 minus x, which is equal to 2x cubed over 1 minus x. In part D, we're given the sequence a sub n equals 2n plus 3 for all n. The generating function for this sequence g of x is, by definition, the sum from n equals 0 to infinity of a sub n x to the n. And by substitution, this is equal to the sum from n equals 0 to infinity of 2n plus 3 x to the n. And we can rewrite this sum as 2 times the sum from n equals 0 to infinity of n x to the n plus the sum from n equals 0, or plus 3 times the sum from n equals 0 to infinity of x to the n. And we have, by a table from the book, this is equal to 2 times 1 over 1 minus x squared plus 3 times 1 over 1 minus x by a theorem. And the least common denominator is 1 minus x squared, so we have this is equal to 2 plus 3 times 1 minus x over 1 minus x squared, which is equal to 3 plus 2 is 5 minus 3x over 1 minus x squared. In part E, we're given the sequence a sub n equals 8 choose n for all n. The generating function for this sequence is, by definition, the sum from n equals 0 to infinity of the sequence 8 choose n x to the n, and we have that by the generalized binomial theorem, extended binomial theorem, it follows that this is equal to 1 plus x to the 8th in part F. We are given the sequence a sub n equals n plus 4 choose n for all n. And by definition, the generating series for this sequence g of x is equal to the sum from n equals 0 to infinity of n plus 4 choose n times x to the n Now recall that for a binomial coefficient, this is going to be equal to the sum from n equals 0 to infinity of n plus 4 choose n plus 4 minus n, which is simply 4, x to the n, and then making the substitution t equals n plus 4. But before we even do that, this is equal to the sum from n equals, not n anymore, it's not going to be t equals 4 to infinity of t choose 4, x to the, and n is going to be t minus 4. And so this is equal to 1 over x to the 4th times the sum from t equals 4 to infinity of t choose 4, x to the t, earlier I made a mistake. So in this we have 2n plus 3 times x to the n. This is the same as 2 times the sum from n equals 0 to infinity of n x to the n plus 3 times the sum from n equals 0 to infinity of x to the n. But I made a mistake here because n is going to be equal to 0. This knocks out the first term in this sum. And so this is actually equal to, if I rewrite it, sum from n equals 1 to infinity of n x to the n and this actually is not something we're familiar with. We'd be more familiar with a different kind of sum. So if we make the change from n to n plus 1, this becomes maybe the easiest way to do this is simply to work backwards. So we have this sum 2n plus 3 x to the n. This is equal to the sum from n equals 0 to infinity of 2 times n plus 1 plus 1 x to the n, and this is equal to 2 times the sum from n equals 0 to infinity of n plus 1 x to the n plus 1 times the sum from n equals 0 to infinity of x to the n, and this becomes 2 times 1 over 1 minus x squared plus 1 over 1 minus x, or 2 plus 1 minus x over 1 minus x squared, which is equal to 3 minus x over 1 minus x squared. Okay. And in part F, you recognize that instead of making the substitution, we can write this sum in the form sum from n equals 0 to infinity of n plus 5 minus 1, and then in the bottom of the binomial coefficient, this is the same as choose n and we have that from the book. We see that in the table this is going to be equal to 1 over x minus 1 to the 5th. Or instead of x minus 1, 1 minus x.